I'll start today and continue tomorrow. Page 49. Please don't listen carefully. Please don't let the terminology throw you off. I think you will understand what I'm talking about. It's just having these terms right that you need to later on add to your study sheet. Okay. Dependent versus independent events. Okay, so that's everything we've been doing so far has been considered independent. So I'll use a different color for independent, all right? These are events where the first does not affect the second. So we're going to start talking about more than one event. Okay, folks, more than one event. So what are events, Mr. Dirksen? A classic one is I pull a card, I keep it right in my hand, and then I go ahead and pull another one, right? So those are two events. But the total possible outcomes remains the same. That's the important thing. So the first does not affect the second. Example, if you draw a card, you record your result and you replace it, okay? Before you draw another, the total remains unchanged. That would be independent, okay? Rolling dice does not affect the total number of outcomes for a second roll, even a third, even a fourth, and so forth, okay? So think of a die. If I roll a 4, right, and then I roll it again, rolling this 3, the 4 that I just rolled has nothing to do with me getting the 3 on my second roll. Like every single time I roll, there's how many sides on this one? 6. It remains the same. The total never changes here. Same with a coin, okay? You cannot remove anything there. So every time you toss, there's always 2 options, okay? Nothing is removed. The total options are the same. That would be independent as well, okay? So rolling a dice does not affect the total outcomes. I will say tossing a coin is also considered independent, okay? So all those things are independent. You're not removing anything, okay? Dependent events, different highlighter. I'll go orange, okay? That's the big difference. Events are dependent when the first event affects the total number of outcomes for the second event, okay? The key word you want to look for is no replacement or some sort of indication of that. If there's one classic one is chocolate, right? A lot of you had more than you should have had last Thursday or Friday. You were eating, right? Every time you grab it from the bag, you're eating it. Obviously, you're not replacing the chocolate, right? So every time you draw, the total number of candies was shrinking, okay? So that would be dependent. So when cards, marbles, candies, etc. are not being returned, okay, it affects the total outcome for the second draw, and it could even be the third, the fourth, and so forth, okay? Another example is your teacher picks random students to come to the front of the class, okay? The chances of you being picked next increase since the number of students remaining, or the total, is decreasing. Okay, so let's do a few questions here talking about these two differences. Okay, so if you want a hint for study sheet, I would definitely say dependent events, no replacement. I would put it right next to it, and then followed by the total number of outcome changes. Right, that's kind of like the trifecta there. Independent, the total is unchanged. You replace. Okay. So I will circle replace, and I will circle not replaced for the right replacement is independent. No replacement is dependent, because remember, the second event depends on what happened first. Okay. So here we go. Let's do a few examples. Hopefully you can wrap your head around this. A bag of marbles has 3 reds, 5 blue, and 2 green marbles. I've already depicted it right here. Okay? If a blue marble is chosen and not replaced, okay, I will highlight that. What is the probability of drawing a red marble next? So this makes it dependent. Okay, that definitely makes it dependent. So, this is the first event. And this is the second event. Just want you to see that, right? You don't necessarily need to do that next time. Okay? So if a blue marble is chosen first and not replaced, we can go to our bag here and go to the blues. The blues are right here. Let's get rid of one. Okay? We're removing it. So therefore, the probability of drawing a red one is going to be, how many reds are there? 3, right? What's the total here? Total is, let's count all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, correct? But I removed one, so now I'm going to cross that off and say there's only 9 left. So this will be 3 over 9. Which is 0.3333 or 33.33%. You could have reduced that fraction. I know that, but so this is the probability of drawing your red one on the second draw. If I hadn't removed anything, it would have been out of 10. Okay, so that's the main concept here, that the total dropped. I went 10 minus 1. And that's how I came up with that number right there. I used to have 10, now I'm 9. Okay? Reset. B is resetting. We forget about A. Okay? It's a different question. If a blue marble is chosen and not replaced, state the probability of drawing another blue, right? So sorry. I'm just going to say this is the first event. This is the second. But obviously we want to focus on this one. We want to state the probability of this happening given that something happened beforehand. How would that change? I will just say probability of a blue marble. Let's go over here. What was chosen first? A blue one, correct? So we cross off the blue. We're left with 9. Right, so 10 minus 1, we're left with 9. So my denominator would be 9. How many blue ones did I have at the beginning? I had 5, correct? Now I'm down to 4. So I'm going to go 5 minus 1 gave me the 4. 10 minus 1 gave me the 9. So 4 over 9 is the probability of drawing another blue one. Turn that into a decimal, that would be 0.4444, which is 44.44%. Can we just add dependent events one more time here? Because that's dependent. That's the highlighter there. Folks, if it doesn't say not replaced, don't worry about what we're doing right now. It's only when it's not replacement. Sorry, what did I say? I feel like I just contradicted myself. If it says no replacement, you need to watch out for this, right? The total drops. Both of them, watch this. For both of them, the denominator dropped by 1 because 1 was drawn already. And the numerator was affected in this case because the blue was drawn one more time. So the 5 turns into 4. Okay. Next. If a red marble is chosen, so this is first, replaced. What does that tell us? What kind of events are we talking about? Independent. You know what I would even say? If something is replaced, why do you even bother telling me what happened first? It wouldn't even matter. It would be absolutely wouldn't make any difference because you put it back, right? But you got to watch out for the wording. What's the probability of choosing another red marble? Is the second event. Probability of red. We've got a total of 10, correct? It doesn't change, it just stays 10. Nothing is removed. How many red ones are there? 3. And nothing has changed because the first red has been replaced, so it's 3 over 10. So it's 0.3 or 30%. Just like that. Okay, we're going to take off the training wheels, and I'll let you do page 50 to 51 on your own until the bell goes, okay? So your homework is just 50 to 51, that's it. I just want you to get going with that, right? It doesn't take very long, and I'll post a key. Thank you, guys.